in addition to talking about equations of parallel lines, we will also be talking about equations of perpendicular lines. Okay. So finding the equations of parallel and perpendicular lines are actually very similar in process, but there is one key feature that is different that will distinguish between the two. Okay, so first, again, let's review that we will be using slope-intercept form. So y equals mx plus b. Okay, m, again, is slope, b equals the y-intercept. Right? Properties of perpendicular. Okay. The slopes are not the same, but they are opposite signs and reciprocal of each other. So opposite signs, let's see this, slopes are opposite signs and reciprocal. Okay. Opposite signs refers to the positive and negative, and reciprocal means that the denominator and numerator are flipped. So you can think of it as flipped. Okay. If I were to draw two perpendicular lines, I want to make sure that I use a symbol. So the symbol in a diagram would be a little red box usually. And that'll show that those are perpendicular. Okay. So we're going to focus more on the equation aspect of it. Let's take a look at a couple examples of perpendicular lines. Okay. Y equals 3x minus 8. Y equals negative 1/3 x plus 4. Okay. So looking at just the slopes, we're going to have 3 and negative 1/3. As I compare the slopes, I can see that the signs are opposite of each other. So this is positive, and then this is negative. Okay. And they're reciprocals. So again, 3 would be the same thing as 3 over 1, right? Which means if I flip that, it would be 1/3, okay? So you can see that 3 and 1/3 are reciprocals of each other. Okay. So I can say that these two lines, or these two equations, are perpendicular. Okay. And just to clarify, because I can see that the opposite signs are there, and they're both reciprocal from each other. Okay. Let's look at an example that is not perpendicular. Y equals 5x minus 2. Okay. Y equals 1/4 x. Okay. And we're just going to leave it like that. So again, we're just looking at the slopes. So we have a slope of 5 and a slope of 1/5. Okay. So looking at the signs, our opposite signs here, their signs are not opposite. So this is not perpendicular. Okay. We can even go on further and see that 5 and 1/4, they are not reciprocals of each other, right? If you flip the 5 over from the numerator and the denominator, you don't get 1/4, you actually are supposed to get 1/5, So even reciprocals are not here. Okay. So this is not perpendicular. Right? We're going to go on and talk about writing the perpendicular lines. So if you watch the parallel lines video, it is very, very similar. The only difference is we're not going to use the same slope like we did in parallel line. We're going to try to find opposite signs and reciprocal slopes. Okay, so we're going to write a linear equation. That is perpendicular to y equals 7x minus 8 and has a y-intercept equal to 7. So a lot of this is very similar to what we just worked on in parallel lines, but the only difference is we're going to look at perpendicular lines this time instead of parallel lines. Okay. So I'm going to highlight the perpendicular lines because I know that's the important feature. I'm going to highlight the original line and also the y-intercept. Okay, so looking at our slope, we had 7 to begin with. But I don't want the same slope, I want opposite and reciprocal slopes since we're talking about perpendicular. Okay, so if my slope was 7, then my opposite and reciprocal slope will be negative 1 over 7. Negative 1 over 7. Okay. So that's my perpendicular slope. Okay. My b value is my y-intercept, which is 7, just like before. Okay. So we're going to start at the y equals mx plus b equation, and we're going to plug everything we have in. So I have my new slope that I want to use, which is negative 1 over 7. So I'm going to plug it into m for my new slope, and my new y-intercept, which is 7. Okay. So I'm going to plug that in. Y equals negative 1 over 7x plus 7. Okay. And you can see that if I compare it to my original line, okay, the slopes are opposite signs and a reciprocal, which makes them perpendicular to each other. Okay, our second example again will be a problem that passes through a random point rather than the y-intercept. Okay, so my original line is y equals negative 2x, and I want it to pass it through a point at 4, negative 5. Okay. So from here, I'm going to get my information. So I have perpendicular lines, so that's good. I want to know my original line, which is y equals negative 2x, and I have my point that I want to pass through. Okay. Again, this point will help us find the actual y-intercept for our equation. So let's go ahead and find the opposite and reciprocal slope. Okay, so the opposite and reciprocal slope, originally the slope is -2, so my new perpendicular slope would be positive 1/2. So it's opposite signs, and it's the reciprocal of 2, which is 1/2. Okay. My point that I want to pass through is 4, -5. So these are the two pieces of information that I'm going to use for my next step. Okay. So let's plug everything in that we know into y equals mx plus b. Okay. I know that my new slope is 1/2. And remember, this point gives us the x and y values that we need to plug in into the equation. Okay. Y equals -5, right? Your slope is 1/2, and your x value is 4. Okay, and then plus b. Now again, looking here, b is my only variable left, so if I solve for this equation, I will get the value of b. Okay, -5 equals 1/2 times 4, which is 2, plus b. Okay. Subtract 2 to both sides, gets us b equals -7. And this is our y-intercept. Okay. So I will be using my new slope plus my new y-intercept to write my final equation. Okay. So y equals 1/2 x, the slope I just found, minus 7, the y-intercept I just found. Okay. So let's highlight that. B was put there, and my slope of 1/2 was put there. Okay. So if I were to compare my final answer to my original line, you can see that the slopes are opposite signs and they are reciprocal.